Hi there. I'm Bruce Betts. I'm the chief scientist for the Planetary Society. And today we've got an amazing group of panelists to talk to you about a range of things, all tied in some way to Planetary Society involvement and member supported activities tied to Mars exploration, but then going beyond that. So we'll hear from Nina Lanza about the SuperCam Mars microphone that's about to land on Mars, from Abigail Freeman of JPL, who went from a student in a Planetary Society program to being deputy project scientist on Mars rovers. But first, we're going to hear from Jennifer Vaughn and from me, kind of talking about the history of what members have made possible for the Planetary Society to do with Mars exploration. And we'll start out with Jennifer. She is the Chief Operating Officer of the Planetary Society, the person who keeps it all together and keeps it running day to day, and has done an excellent job. So I go ahead and hand it over to Jennifer.
Thank you. It's so good to be here with you all. And I always have to say, when someone introduces me that way, my job is easy. My job is easy because our team is excellent and our mission is amazing. So I'm excited to be here today with my dog to go over how you have made a difference. So I'm going to start by sharing my screen, which will just take me a moment. And I'll move this over. All right. So you are a Mars explorer. And I mean that from the deepest sense of my heart. You are a Mars explorer. And we're here to talk today a little bit about how citizen funding and how public support has really shaped Mars exploration, including where we are right now. So I'm going to start with a few bold statements. We're here on Mars now. And it's you who helped create NASA's Mars exploration program. It's you who helped develop rover technology. And it's you who helped initiate public involvement in missions to other worlds. So we'll go over this a little bit more, and I like to use a lot of old materials you'll see. So first, let me set the stage. It is 1980. So very different time than it is right now. It's the middle of the Cold War. Major players in the Cold War, US and USSR, the Soviet Union. Not surprisingly, we were the two most developed space agencies as well. So this is all tied to the space race that had happened in the 1960s. So in 1980, there we were. We had built up a lot of capability very quickly in space exploration. But then 1980, we're looking forward for the US Mars program, and there was nothing. What this graph shows is the Mars funding line for NASA. And you'll see earlier on in the years, so in the 1960s and early 70s, nice strong funding because we had a lot of work. We had the Mariners, we had Viking landers, Viking orbiters. And then you see this sharp falling off in the late 1970s into the early 1980s. This was very concerning because it wasn't just the Mars program. It was really all of planetary exploration at NASA. So in the US, there was a very clear understanding that there was a bit of a crisis here. We'd built up all this capability. The public was so excited about what we were learning about the solar system. And now when we looked into the future, there wasn't anything much more than the shuttle to look forward to. So Planetary Society was born. This was the whole impetus for the Planetary Society. Our founders, Carl Sagan, Bruce Murray, Lewis Friedman, they knew that there was a public appetite for space exploration. They knew that the public really demanded to know more about our solar system, our cosmos, and our place within it. So we were founded to prove that public support, because that being able to prove that there are these masses of people who want this makes it that much easier than to push for programmatic investment. So the Planetary Society held a very, very special role, though, and still holds a very special role in the world. And these are the factors that help us really be distinct. So one, we are independent. We are not only nonprofit, we're non-governmental, we are publicly funded. So we're funded by a mass group of people and not held to any one particular funder. and we're international. So our perspective has always been broader than just what was happening in the US. It's what's happening in the US and in relationship to everything else that could be happening in the world when it comes to space exploration. So these factors really set us up for a place in the world to be able to advocate in a very nimble and assertive way. We started with a lot of public, I'm sorry, I forgot this one great quote that I just read. So Lewis Freeman, one of our founders, just had this recent book out. You can get it online, called Planetary Adventures. Talks a lot more about what I'm going to address today. And he wrote in 1980s, it was the only decade since the beginning of the space age without a US mission to Mars. So this is why we formed the Planetary Society. Inspiration was needed. So indeed, we were out there to inspire, we were out there to educate, we were out there to advocate for future Mars missions. So it started with some early collaboration because of relationship building. Our founders were very well connected, and they were very quickly introduced to some high-ranking high-ranking space officials in the USSR. So from those relationships, very quickly in 1984, we were able to organize a conference in Graz, Austria at the time. And we were able to bring a private group of people together to talk about what collaboration between these two entities, these two enemies at the time, what space collaboration might look like, where we could bring our expertise together and actually help pursue exploration in the solar system. It's important to note that at this time, I already mentioned there was nothing planned for the US. There was quite a bit on the books for the USSR. They were still active with their planetary program. So this was a big reason why the organization worked so hard to develop these relationships and to develop opportunities. So from this very first conference that we had, we developed this report. The report got distributed, of course, to decision makers. Carl Sagan started a very vocal campaign for Mars exploration and working together with the Soviets to go to Mars, both robotically and human exploration. Let's Go to Mars. This was an essay that he did for Parade magazine at the time. So for those of you who were around in the 80s, know how popular Parade was. It was in our Sunday newspaper. So it was one of the things we all expected to be able to read and learn from. So that he, of course, published for the Planetary Report as well. We started our own publication, or took over one that was just starting, called Mars Underground News. This was really to help bring the community together, the Mars community from different nations. We published a full-page ad, The Way to Mars, with our Mars Declaration. It's so big, I couldn't actually get this all put together for a PowerPoint, but I got the top part of it here, where we had 250 people, notable people, sign on to this to say, we really want to go to Mars, and we want to work collaboratively with other nations. And kind of as we're nearing this shift that's happening from this period where nothing was happening at NASA around Mars to all of a sudden a Mars program coming into being, the then administrator, Dan Golden, asked Carl Sagan to really help with the rationale behind. So Carl wrote this very popular essay, Why Mars? And it's something that you can still find today. And we have it up on our website too. Really compelling reasons for why Mars is such a destination that draws us, it beckons us, is the word that Carl would use. So while all of this was taking place, we were advocating, we were educating, but we were also, based on our relationship, starting to build out projects. So the first project that we did was a Mars balloon. And I'm sorry, the first Mars-related project. We'd already been involved with projects since our founding. But the first Mars-related project was this fanciful idea at the time of having a balloon that would explore and be able to overlook the surface of Mars from a very near distance. And we were able, through our connections, to have an official role on a Soviet mission at the time. So it was to launch in the 90s. It had multiple names because the date kept moving down. So it was 92, 94, 96, but a Mars mission. And we were involved with the snake, the rope, the tether that holds that balloon. So that really got things started. And that's a story in and of itself that I encourage you all to understand more about what we did with the balloon. But I want to go from there of what happened next. Because of our balloon tests that we did, because of our relationships with this international Mars community, especially the building and the relationship with the Soviet scientists, we were asked then to do Mars rover testing. So we were called out to Kamchatka, a peninsula, a very remote peninsula in the Soviet Union at the time, in Russia now. And we were called out there to watch and observe and give feedback on how they were testing their prototype rover called the Marsicon. So this is a nice little spread from our magazine that showcased the rugged environment, and seeing this rover kind of moving around. This was still a relatively new idea, and one that was not so easy to necessarily sell to a space mission, because rovers take up they take a lot of mass. So you have to give up other things in order to send a rover. That's a big challenge. So we continued with this. We actually organized a very large rover test out in the Mojave Desert. Yes, yes, I'm sorry. And so from there, we brought a lot of the scientists to the US, had this great rover test out in the desert, and then did yet one more where we were still testing out in the desert. And this picture, I'm just going to zoom in on a little bit, because you can see in the bottom corner there, the person that has glasses in the front, that's Dan Golden. So that is the NASA administrator at the time, actually getting a chance to teleoperate. So from a computer, operate a rover in a very distant location, from a desert location. So this was all hands-on, showing what the capabilities really are for rovers. We did one more roundup where we had really a number of international players. We're very proud of that. Come out to the California beach area, Santa Monica Beach, and do a very public-friendly rover roundup where just the general public came and watched rovers perform. So one more little thing, little side note here, as this all kind of generates to one conclusion here. In our relationships with the Russians, we also had this opportunity to, for the very first time, send the names of our members to another planet. And so this was a thrilling idea for us, that we could actually have our members journey virtually this way by having their names fly. And the little instrument that the names were, the little microlithography that took place, that instrument was also slated for by now it was Russia. So they shifted now, a Russian lander, and the spacecraft didn't make it. So we had, with our names and our visions of Mars that you'll be hearing more about, we had a lot invested in this spacecraft, didn't work out. However, that little payload ended up going on the Pathfinder mission to Mars. So that would mark really the first time that names from humans landed on another planet, and started a whole new process of getting people involved by sending your name around the solar system. Very exciting. I'm almost done here. So as we were kind of ramping up, we now had an idea for our Pathfinder mission. It was going to go. We had the go-ahead to send a rover as well. Very exciting little micro rover. We were able to run a contest to name that rover. We have this great shot. It's a little blurry, but best one we had of our winner at the time, who chose the name Sojourner Truth for the rover. And all of this leads up to the rover landing in 1997 and our first Mars-related Planet Fest. This Independence Day, Earth invades Mars. It's Planet Fest 97. And we got together with about 5,000 people and waited as the telemetry came in to say that the rover and the Pathfinder were safe. And then we got this wonderful image letting us know that all of this work, everything that led up to it, it was all coming in here. We had a rover on the surface of Mars. NASA had a budding program. The names of Planetary Society members were on that. And there's even a passive experiment also that was funded by everyday people to be on that rover as well, or on that spacecraft as well. So this is a kind of a through line story that it takes decades sometimes to see these things pay off. but it's you. It's the people who got involved with the planetary site. It's the people who actually reached out and tried to get lawmakers to support missions. It's you who spread the joy and excitement about space exploration. You're the ones who are pushing space exploration forward. So with that, this only takes us to 1997. So I'm going to hand it on over to Bruce now. I'm going to stop my share. And Bruce, take it on over.
All right, we've made it to 1997. There's lots more good stuff the Planetary Society was involved with doing, some of which were continuations of things that Jennifer talked about, some of which were totally new things. Let me do a screen share, if I can get it right. Let me know if you can't see that. So part 2, and we have a pretty picture here. We'll talk more about what it is, but that little mini DVD came from the Planetary Society, and we're excited it got covered in Mars Dirt on the Phoenix lander. But let's go back a little bit more to the Mars microphone. So this was advocated by Planetary Society in the 90s, including Carl Sagan, with direct letters to NASA saying, wouldn't it be great if we had a second sense on Mars besides seeing things in pictures, if we could hear it? And also there may be science that could be done as well, but it would just be publicly engaging, which is part of what we're all about. That and dogs, always dogs. Oh, they are unhappy. It must be the mail carrier. Okay, so Mars microphone, we actually successfully flew it inside an instrument on Mars Polar Lander, went to Mars, it's on Mars. Unfortunately, Mars Polar Lander crashed. But this did represent the first privately funded active instrument, or it would have been active. It didn't crash. It was then selected to be on the French Netlander missions, which were canceled. We were outreach partner with a microphone that was included as part of the descent imager on the Phoenix lander, which due to software problems was never turned on. We did collaborate with Huygens at a different body at Titan, Saturn's moon, and process some acoustic sounds to be Titan sounds. And we had tried to get microphones on other Mars missions, kept advocating for it. Perseverance, good news, flying 2 microphones, not Planetary Society microphones, but we like to think we had something to do with promoting this idea, getting people excited about hearing things on Mars. There are the entry, descent, and landing has microphones. And what we're going to hear about today, which is Los Alamos National Laboratory's SuperCam instrument, includes a microphone on Perseverance, and we'll be collecting sounds from the Mars surface. And I'm excited that next speaker, Nina Lanza, will be talking about that. Then with the Mars Exploration Rover Spirit and Opportunity, we had a big involvement, a lot of educational outreach activities, things designed to engage the public. This was called Red Rover Goes to Mars. It included a mini DVD that flew to the surface and included 4 million names collected by NASA and the Planetary Society, also Lego bricks, because we had a partnership with the Lego group and a Lego minifigure on there. There are Lego minifigures named through a contest, Biff Starling and Sandy Moondust, who told their stories on the rovers. And then success. That arrow points to the DVD on the lander, on the Spirit lander, and there's one on the Opportunity lander, and a closer up picture. And you can see our friend, the minifigure, and we had secret codes on there to engage people in a secret code decoding. We also ran the contest that led to the rover naming, and that was young me with young 9-year-old Sophie Collis, who suggested the Spirit Opportunity names. And then we had a big effort selecting competitively 16 students from 12 countries around the world, training them, and then getting them involved at JPL at the time of landing and for a while after in mission operations. And keep an eye on that person because she'll be talking in just a little bit. We also had them, in fact, we had them working with the calibration target from the camera system. And turns out, especially Bill Nye, who happens to be he's a sundial fanatic. He said, hey, those things look like sundials. So we turned them into Mars dials, added some hour marks for using the shadow to tell time on Mars. What happens when you put these things on the surface of Mars and then leave them there for a few months? They get really, really dusty and dirty, but they've got magnets in them, as did our DVDs. You can see that circle. It ends up clearing away a relatively dust-free area as well. All right, 2007, 2008, silica glass mini DVD. And again, by the way, they're silica glass because they need to be baked out for planetary protection so that they're not carrying any living creatures with them. And so you'd melt a regular mini DVD, and other technologies weren't prevalent at the time. And so on Phoenix, we included this. And indeed, there's our picture with Mars dirt on our mini DVD. This included not only names, but the first library on Mars, Visions of Mars. And that included a range of Mars literature and art. It's basically a time capsule for future explorers looking back at what humans thought about Mars. Because some of the content was put together originally for Mars 96, we were fortunate to have Greetings to Future Astronauts include Carl Sagan and also our founder Lou Friedman, as well as Arthur C. Clarke and Judith Merrill. So looking ahead, that's kind of things we've done. We've funded the PlanetVac surface sampling technology to planetary vacuum to grab samples from the surface done by Honeybee Robotics. So members facilitated this. We stepped in at two critical times in development. One where they were doing vacuum chamber tests at Mars pressures to see whether the basic system would work. And a few years later, when they were testing it on a Masten rocket in the California desert in a more realistic setting. And just as an example of where we were able to give relatively small support at critical times to keep this going, now it'll be flying to not Mars exactly, but Mars's moon Phobos on the Japanese MMX mission, doing sampling of Phobos, which will likely include some Mars materials that were ejected from Mars and impact. And that'll be arriving at Phobos in 2025. As a side note, they also were selected for a technology demonstration going to the moon even sooner. So we're very proud and excited for Honeybee Robotics. Looking to the future, this is broader than Mars, but we've just announced a new grants program, and I couldn't resist mentioning it. The STEP grants, Planetary Society Science and Technology Empowered by the Public grants, which are open to planetary science, technology, open, international, competed. Pre-proposals due May 26th. So we're looking to solicit new exciting ideas there. So let me give some wrap up here. Hit the right button. Okay. So we continue to do a lot of things, and some of which, some things that I didn't focus on as much, I want to mention now, which is in addition to the hardware we've been involved with and promoting things like microphones, we also continue to do education like this activity, like our great website, like Planetary Radio, and we're always tying that back periodically to Mars. Also, we have a whole political advocacy activity that's been pushing hard and in fact pushed very hard for sample return, which now is happening. And we'll hear more about sample return in a session that I'm chairing tomorrow. But right now, I will continue my very short bio intros. By the way, there are more complete biographies of our speakers on Whova that you can find from this session, you can link to. And I'm really excited that we've got Nina Lanza, Dr. Nina Lanza from Los Alamos National Laboratory. She is She is the lead for space and planetary exploration, the team lead there, and she is involved with the SuperCam as well as ChemCam on Curiosity, but SuperCam instrument on Perseverance that includes a microphone. And she also has done all sorts of other great science that I'm not going to mention right now. I turn it over to you, Nina.
Well, thanks. I'm excited to be here. And don't worry, I'll tell you all about some science in just a moment. I'm just going to share my screen. Give me one moment. Okay, well, I am really excited to talk to you about a different Mars microphone that, fingers crossed, is going to get to Mars this coming week. Crazy. And that's the one that is on the SuperCam instrument, which is on, of course, Perseverance. And so I'm showing you an image right now. If you can see, this is the very top of the rover. And you can see that there's a little orange arrow, and that's where our microphone is. Our microphone is like an ear with the Cyclops eye of the SuperCam instrument. So let me tell you just a little bit more about SuperCam, just to give you some context. So this is actually many instruments in one. This is a collaboration between the US, France, and Spain. So it's a very international collaboration. And SuperCam can do a lot of things. So the main thing that we can do is do chemistry. So that's figuring out what elements are in a rock. And we do this with a really cool rock vaporizing laser technique called laser-induced breakdown spectroscopy, or LIBS. And you can see an artist's conception here in this image of what that looks like. It's actually in the infrared. It's at 1064 nanometers wavelength, so you couldn't actually see it, but we're going to let that slide. It's hard to show an invisible laser in a slideshow. So we can do chemistry with our laser technique, but we can also do mineralogy. And this is really important because geologists need both chemistry and mineralogy to be able to understand geologic materials. Chemistry is the elements, and mineralogy is how those elements are arranged. So we actually have several ways of figuring out mineralogy with SuperCam as well. Our main technique that we're using is another laser-based technique called the Raman Spectroscopy. And so that uses a slightly lower power laser to figure out what the bonds are. So that's a mineralogical technique. We can also do passive spectroscopy, so no laser, just take a look at what the surface looks like from the sun's light. So we can do visible and near infrared passive spectroscopy to understand mineralogy as well. And we can also do time-resolved luminescence, which is just a technique that uses the Raman laser to understand trace elements within mineral structures. So along with chemistry and mineralogy, we can also study morphology, so shapes, with a color camera. So we can take all this chemistry and mineralogy information and put it into a geologic context with some really beautiful images. And then along with all this, we have a microphone. So you may wonder, why do we need a Mars microphone at all? Like, how does this fit into the science that we want to do? And it's not just to hear what the Martians have been saying about us this whole time, although we can do that as well. There's actually a lot of really cool science we can do. But before I go into that science, let me talk a little bit about why sounds might actually sound different on Mars. And so you probably already are aware of this, but what we're calling sound is the vibration of air. So my voice is vibrating the air, and it's actually going through some mechanical assistance and coming out the other end and vibrating air near you. And then your ear is detecting that. Your ear is a microphone detecting my voice. So we can use other things beyond just air to make vibrations and to make sounds. Sound can travel through liquid, can travel through rock. We tend to think of it as something that's happening in air just because that's how we use sound. But depending on what you're vibrating, the properties of the sound are going to change. And so the Martian atmosphere is actually quite different from the terrestrial atmosphere. The Mars atmosphere has a different composition, density, and temperature. Those are the big ones. So it's about 6 millibar pressure. So that's pretty low pressure, 6/1000th of what we have at sea level here on Earth. It's carbon dioxide, which is a very different composition. We've got a lot of other stuff in our atmosphere. And it's typically very cold. So usually it's below 0 degrees Celsius, in general. So all these things make sound different. So How does this work? So first of all, the speed of sound is slower on Mars, and that's just because of the lower atmospheric density and temperature. This is something that probably you wouldn't notice right away if you found yourself, unfortunately, on the surface of Mars without a helmet, but it's something that might make a difference when you're hearing sounds being propagated over long distances. So something you would notice up close is that sounds are much quieter. So you're going to have to be closer to the source of the sound to be able to hear it. And this is just because of the lower atmospheric density on Mars. And finally, lower pitched sounds are actually going to sound louder than higher pitched sounds. And this is just because of the composition of the atmosphere. So that would actually probably be really weird. So my lower tones now, if I'm speaking low, would be louder than if I'm talking here. And so it would probably be a little disconcerting to hear somebody speaking on Mars just because it would sound a little bit different. Things would be modulated differently. So here's just an example. This is just different sounds and what their frequencies are, just to give you some context. So along sort of the x-axis is just the frequency in hertz. So that's cycles per second. That's how many vibrations are hitting your ear per second. Right in the middle, you can see in this orange box, that's the human voice. The human voice is usually around 100 to 200 hertz. That is actually something that our microphone, which you can see in the top in pink, that's something is covered by the bandwidth of our microphone, which is about 100 hertz to 10 kilohertz. So we can record the sounds of our own voices should we find ourselves on Mars. But there are some other things we can listen to. So of course, you can see here some natural sounds that we're very interested in. At the bottom, you can see aeroacoustics. So that's wind type sounds. So typically wind can actually make some really low frequency sounds, but we can still hear higher pitched wind sounds with the microphone. So that's going to be really exciting. We can also listen to the sound of vortices. So that's a dust devil. You can see a lot of that. You've probably seen images of that on Mars. Again, a lot of them have a little bit lower frequency range than our microphone, but we can still hear them with our microphone. And then on the higher pitch side, we can hear saltation, which is just the movement of sand grains being pushed by wind. So it's a little bit higher pitched, and we can hear that as well. But we're also bringing our own sounds to Mars, it turns out. So we're bringing this whole rover, so we can hear the sounds of rover activities, actuators turning, motors going, all kinds of things. And specifically, we can hear the sound of the Libs analysis. The Libs acoustics actually makes a sound that's right in the middle of our microphone bandwidth, and that was by design. So I can tell you a little bit more about that. So really the question is, what can we learn from listening to sounds on Mars? Just broadly, most generally, we can refine our model of how sounds behave in the Martian atmosphere. We have models and we've done some experiments in big Mars chambers on Earth, but there's no substitution to actually taking data in the field. So we'll be able to refine our understanding of how sounds propagate through the Martian atmosphere by taking data on Mars. And we'll be able to also learn a lot more about atmospheric processes like wind and dust devils, which are pretty common. Aeolian processes are the dominant process on Mars today. So we'll be able to learn a lot more about them by listening to their sounds. And of course, we'll be able to listen to the sounds of the rover. I'm showing a little image here, a little GIF of the wheels driving. This is in the test bed at JPL. And so these wheels are, this is actually Curiosity's wheels, but they're similar to Perseverance's. They're metal wheels on rock. And I will tell you right now, that is not a beautiful sound. That's a really high-pitched sound. I think it's something we'll be able to hear very clearly with our microphone, which still should be pretty interesting. But we're also collaborating with other instruments to help them understand how their instruments are functioning. And one notable collaboration is with the MOXIE instrument, which is the instrument to make O2, oxygen, on the surface of Mars as a tech demo. And this is for a future mission with humans. We need to be able to make oxygen for both breathing and for rocket fuel. So they've asked us to actually turn on our microphone while they're running their compressor, because it turns out the sound of their compressor gives them a good sense of how well it's functioning. So they can listen to the sound of the compressor and understand the state of health of their instruments. So that's a really exciting use that we can do. But all of this is great, but the main reason that we actually wanted to put a microphone on SuperCam in the first place is to listen to the sound of that LIBS laser, the laser-induced breakdown spectroscopy instrument that's finding chemistry. And so why are we doing this? So LIBS, it turns out, produces a shock wave. So the way this works is we shoot the laser, we heat up a sample really hot and makes a plasma. We just vaporize the material, make a plasma, and that plasma expands outward. You can see that in this image here. That's a still image of that plasma. And it's moving really fast, and it's fast enough that it's faster than the speed of sound. So it makes a shock wave, and that's what makes the acoustic signal. Now, it's not quite a pew pew. I was disappointed too. It's more of a snap snap. That's the sound it makes. So it turns out that the LIBS acoustic signal can actually provide a lot of information about the rock that's being analyzed. So you can find out things like the material hardness, the depth to which the laser is penetrating, because every time we shoot the laser, we're digging a little more of a hole in the rock. We can also look at changes in the material properties with the depth as we are shooting into the rock. And very importantly for my research, we can actually hear the sound of the laser penetrating through rock coatings, which I think is really exciting. And this is because rock coatings are really a great place to look for habitable environments and life itself. So rock coatings are these sort of pasted on layers onto rock surfaces. We see them all over the place. I'm showing an example here of a classic rock coating that we see in the desert. This is rock varnish. And so it's a dark, shiny coating that covers almost all the rocks in the desert. You've probably stepped on it a million times. It's actually really exciting. So these coatings develop due to interactions between the rock and water, the atmosphere, and on Earth, life. And so it can provide us with information about climate, so what environments have the rocks been exposed to, and habitability, which is environments in which life as we understand it could exist. So it can give us clues about habitability. And it can also potentially, these rock coatings can potentially give us information about actual biosignatures. They might be extant or they could actually be preserved. But either way, this is a great environment for microbes to live. So that's why coatings are so important for the Mars 2020 Perseverance mission, because two of the major goals of that mission are to, first of all, identify potential biosignatures, and then to cache samples for a future return to Earth. So rock coatings are a great target for both of these goals, because not only are they a great habitat for life, they can actually preserve traces of past life. And you can see that in this scanning electron microscope image right at the bottom. You can see there's like this rock varnish coating, and there's all these little microbes in there, and they probably have done a lot. They've helped create that coating and also are helping breaking it down. So excitingly, the LIBS acoustic signal can actually help us to identify samples that have coatings and therefore are really important for being considered for these return samples to Earth. So with that, I just wanted to leave you with this. So, we've talked a lot about, folks being really interested since the 80s about listening to Mars, but people have been wanting to listen to Mars since way before then. And so this is a picture of the great father of radio, Marconi, trying to listen to Mars during a close approach to see if Mars had anything to say to us in radio frequencies. We laugh now, but why not? If we wanted to talk to Mars, that's how we do it. So now, so here we've listened to Mars from Earth, and now we're going to go straight to her and see what she has to say in person. So with that, I'll end.
That was great. Thank you so much, Dr. Lanza. It's so exciting to actually have a microphone about to land on Mars, and you're not only doing great public excitement with it, but all sorts of great science. So thank you. Let us move on to Dr. Abigail Freeman, who is a research scientist in the Planetary Science section at NASA JPL, and is also the deputy project scientist for the Curiosity rover right now. And she'll be telling us more about her background, I think. She was a student astronaut, as we saw in one of those pictures with the Planetary Society way back when. So Abigail, I turn it over to you.
Fantastic, wonderful. Thank you so much for having me. I'm so thrilled to be here at Virtual Planet Fest 2021. The Planetary Society is an organization very near and dear to my heart, and hopefully in this presentation I will convince you why. So let's go ahead, hit the correct button here. Boop. All right, so I'm going to talk to you a little bit today about my journey as rover student astronaut to rover deputy project scientist. And I hope this shows both the value of the Planetary Society's educational programs, but also a concrete example of the power of space exploration to inspire as it's inspired me, and hoping that you all will also use this as an opportunity to think about how space exploration has inspired you. But let me introduce myself and what I do. This is what I spent yesterday morning doing from 8:30 in the morning to about 10 in the morning. I, along with about 30 or 40 other scientists around the world, spent time looking at this particular image. This is where the Curiosity rover is currently parked right now on Mars. And yesterday we had to come up with the list of activities that the rover would do over the weekend, occurring right now, to collect data about all of this terrain that we're currently in. Go ahead and just orient you a little bit. We're actually sitting in a deposit of rocks that are very rich in clay minerals that were deposited in an ancient lake, probably 3.5 or 3 billion years ago. And this lake was probably around for at least millions, if not tens of millions of years. Tantalizingly, just off in the distance, we can see it's about 350, 400 meters away. There's this gorgeous outcrop of rocks that looks a little bit different, which we can actually see from orbit are salty, or rocks rich in a mineral called sulfate. And we think that once we reach those rocks, we're going to start to see evidence of some of the big environmental changes that happened on Mars as it transformed from a warm and habitable environment to a much more arid and dry and less hospitable place. So what did we want to do here? We're limited in the time we have, the power, the data volume we can downlink. This is what we came up with. We're taking some color mosaics of rocks in the near ground to look at their textures, in the foreground to see where we're headed. We're also pulling out our rover arm, and it's actually probably happening right now on Mars, placing on that rock target right in front of us, collecting information about the chemistry and the high resolution textural information. And then also in our plan, we have a drive that's planned that's going to take us along this red line. And on Monday, actually Tuesday because of the holiday, but we're all going to wake up and we're going to be over there. And it's going to start all over again. And we're getting ever closer to this big environmental transition. Okay, but hold on. Let's step back. This is my life. This is what I get to think about every morning. This is what I do. And, I want to share a little bit about how I ended up in this situation. So let's step back to about 2003 when I was a high school student who loved science, who loved space. I didn't really know what I wanted to do, maybe be an astronomer, maybe be a high school chemistry teacher. And I stumbled upon the Planetary Society's Red Rover Goes to Mars contest that Dr. Betts just mentioned. And in particular, I was so excited to be caught up in their student astronaut program, where they selected 16 of us from around the world to go to be at the Jet Propulsion Laboratory during the time that the Spirit and the Opportunity Mars rovers landed and operated on Mars. As part of this program, we not only got to be at JPL for the rover landing, we also got to learn all about the field of planetary geology. And our mentor, Emily Lakdawala, taught us about the types of rocks that are on Mars, remote sensing, how you operate a rover on Mars. And so gaining all of this knowledge through the Planetary Society, and then being able to come out to JPL and being in the room with the scientists, interacting with them, seeing how excited they got over certain rocks, that was certainly eye-opening to me. It taught me about this whole new field of science that I had no idea existed. And it showed me that there are actually people whose job it is to think about how we can explore our solar system with robots and robotic exploration. I was fortunate that I actually got to be at JPL the night that Opportunity landed. And it is definitely that night that set me on this career path that I am now. And to put you a little bit in my mindset, this was the view of Mars that we had before Opportunity landed. It was this very rocky planet covered with these dark lava rocks that had been shaped into these angular, sharp features by the Martian wind. And then the whole surface was covered by this very bright, rust colored Martian dust. But the night that Opportunity landed, I think that changed, and it changed completely. This is what Opportunity saw at that landing site. And it is just so different from anything I had ever seen. I think anybody had ever seen on the surface of the planet. And being able to see that Mars was this completely diverse and world that needed to be explored, that had so much still to show us, was incredible. But I think even more exciting, being able to be with the scientists when these images came down and having them look at this image and go, oh my gosh, I think I see bedrock. I think I see cross bedding in the bedrock. This is amazing. I wanted to know what that meant. I wanted to know why people cared about bedrock. What the heck was cross bedding? What did this all mean? And understand the tools that geologists can use to take a look at a scene like this and understand that this actually represents the site where we once had salty dunes blowing across the surface of Mars that were then cemented by later rising groundwaters. We learned all of that through looking at images in the rocks like this in our rovers. And of course, this is one of my favorite images from the time, seeing images like this come down and just completely blowing my mind about what planetary exploration could do, and the fact that this really is exploration. We really were seeing things for the first time. Since then, this is my career path, and it's plotted along the path that Opportunity took. The mission was supposed to only last for 90 days. And as a high school student, I thought maybe if I'm very, very lucky, one day in the future, I'll be able to participate in something similar. But the rover lasted for 14 years. And in that time, I was able to go to college. I did a research internship with the former Planetary Society president, Jim Bell, looking at data from the panoramic cameras and that Mars dial instrument. Went off to graduate school, where I was a graduate student with the deputy PI for the mission and became involved with the tactical operation team of Opportunity. Picked up my PhD, came over to Caltech, where I postdoced with the now Planetary Society president, Bethany Ellman, before starting at JPL. And shortly after I was hired, I was appointed as the deputy project scientist for this mission. And I had the fortune of serving in that role for about 2 years before we had our last communication with the rover due to that global dust storm. And then interestingly, that was exactly 2 years ago today, was when we had that final press conference. And so here's a picture. There I am up on the stage in Von Karman Auditorium at JPL, celebrating the team that made this mission so successful. Obviously, the Opportunity mission had a huge impact on my life in terms of shaping where I went with my career. But it also had a huge impact on how we viewed Mars. This is an image of the final panorama that Opportunity sent, the legacy pan. And I think this shows, it highlights two of the major things that Opportunity and the twin Spirit showed us. First of all, Mars is a geologically diverse place. Not only was it once a wet planet, it had multiple times where we had water that shaped the surface, groundwater, lake water, over many periods in Martian history. I also love that you can see the tracks in this image carved into that Martian dirt. And what Spirit and Opportunity both really showed us was the power of having a mobile robotic explorer. We were, as Bethany said in her talk, able to go on Martian hikes now to see a huge array of Martian geology. Let's flash forward to 2012 when we had our next rover, Curiosity, land. Here's a picture from landing night. You'll see Nina's right there in front. I'm up in the back a little bit, but again, we're seeing in these images a new Mars that we'd never seen before. This is so different from Spirit, from Opportunity, from Insight, from all the landing sites we've seen. Curiosity landed at the base of this giant Martian mountain, Mount Sharp. And this was the first time we saw it from the ground, tantalizing as we wanted to climb it. And indeed, we have climbed it. We're now past Sol 3000. This is a recent image we took looking towards the rim of the crater that we landed in. We're about 400 meters high, climbed up on this mountain. And with curiosity, we've gone beyond the fact that Mars once had water. We now know it was once a habitable place. It had the building blocks of life, organic molecules, and it had these wet lake environments that persisted for tens of millions of years. So I'll just wrap up by hoping I can share some of my excitement about what's going to happen next Thursday, which of course is the landing of Perseverance on Mars, and just starting to think about what are you going to see when those first images come down from Mars? What are we all going to see? Hopefully these will inspire you. Hopefully programs through organizations like the Planetary Society will inspire you to reach out to your friends and neighbors and family and share the excitement of planetary exploration.
Thank you. That was great. We'll now take some questions that have been entered into Whova, and I'll pass them around to the group. I'm going to start with Nina, and then we'll go to Jennifer. So for Nina, I'll combine some questions. They basically had to do with what do you think we'll hear? So will there be, from Geo asks, will there be enough atmosphere for the mic to pick up the sound of wheels crushing rocks? Nick kind of added whether it would be a quieter sound than on Earth. And then finally, a separate question of whether you'd be able to hear the drilling for sample collection. Would that teach you anything?
Yeah, all really great questions. So I think all the sounds will be quieter, but I feel pretty confident that we'll be able to hear sounds that are close by, like the wheels going over crunchy rocks. Certainly the drill, that's going to vibrate the whole rover. So I think it'll be hard for us to miss that. Yeah, so it'll just be a little bit, it's just a little bit quieter. I feel pretty confident saying this because I'm actually, this week and next week, I have the worst timed experimental work in the lab right now. I'm working with a giant Mars chamber to actually study Mars acoustics. So I have this huge chamber with microphones in it where I can make all kinds of sounds and figure out how sound is propagating. And while sounds are quieter, we can hear a lot of things, and with the similar mics to what's going to be certainly on SuperCam. So I feel good about that. And regarding the drill and what we can learn from that, that's a great question. I'm not sure. I'm sure we could learn about is the drill actually operating correctly? I'm sure the drill team knows what the right sound is and what the wrong sound is. But as for science, that's a really good question. I wonder, that's something that we should probably think about. Maybe we can learn something about how hard the rock is, which is an important question, especially as we decide what rocks we want to drill. Yeah, great idea.
Great. Now to Jennifer. Does the use of crowdfunding offset the pressure for governments to support space exploration or improve the support by showing public support?
Great question. Yeah, I think so far it's really been the latter. But of course, I also think this is fairly new, this idea that individuals will contribute and on the kind of level that we're talking about with crowdfunding, but also with the kind of personal investment that's taking place on the commercial side. So there's a lot of new things that are happening right now. But what we really have found is when the crowd is excited about new ventures that maybe carry a little bit more risk, that we don't really know necessarily the outcome, they're the ones who come in quite often with that belief in supporting an idea. And so I think the Planetary Society has that history of good ideas ending up being tied in with our members and then kickstarted. And then in time, those being adopted by usually government projects at that point, because that's where the big projects really are emanating from. And so I think that the examples that we just saw right now with microphone is a perfect one. where this was on the early side of things, we were clamoring saying, we want to hear Mars, we want to hear Mars. And at that time, it really wasn't a primary goal of the science teams on upcoming missions, but kind of that push to get something started. And then in time, it being adopted, and now it being done at this level is, so much more than we ever expected back in '99 when we did ours. So I think it's really more of a kickstarting to support ideas that then get adopted by larger entities like government.
Great, thanks. Another one or two for Nina, which is, will we hear the landing, and what will this first sound we hear be? And obviously you got a couple microphones to respond about.
Yeah, sure. So we are not going to be turned on during the landing. That's for the entry, descent, and landing microphone. There's actually a whole microphone that's going to do that. So that's going to be awesome. We are going to hear the sounds, just not from SuperCam. So as for SuperCam's first sound, gosh, that's a great question. We know approximately when we're going to turn it on. I bet our first thing is going to be a state of health checkout. And so it'll probably be just the sound of a gentle Martian breeze. That will probably be our very first sound, but it certainly won't be our last sound.
It sounds so relaxing. A gentle
I think it will
Martian
be.
breeze.
Once
Just
we land
hanging
safely.
out. And
I think about the music that will be made from these sounds. It's going to be exciting. I'm sure there's going to be some great creative compositions that come out of it.
Oh, great. Yeah, exactly. I'm like, all of this is going to be publicly available. So please take it and run with it, everyone.
Let's see. Question for Jennifer. Let's just summarize the first part. When we bring back samples from Mars, would it be a good idea to keep a part of it to sell in small pieces to the global crowd to obtain funds for further Mars exploration?
Yeah, quite the entrepreneur out there, huh? Interesting idea. My guess is anything that comes back in the near future, it wouldn't be applicable, because this is going to be government funded projects, and therefore already owned by the people in many ways. They're there for science. So I find it hard to imagine that those would then be up for sale in any way. But it is interesting because, of course, we're in this new kind of entrepreneurial time with space, and what might happen if we see commercial entities get all the way to Mars. That might be something that they would be interested in doing. I hadn't really thought about that before.
All right. How about, just moved, sorry. How can today's students and members be more involved and work on Mars like Nina and Abby? Jennifer, did you want to take that, or you want me to?
Yeah, or you can.
No, go for it.
I was going to say that there's a number of ways. Of course, there is the way that I think all three of our other panelists have gotten involved, which is study a STEM field that is related to exploration. There's many ways, as we all know, space exploration, planetary exploration crosses over so many different areas of science. And so if you have a passion for a particular field, you can start moving in that process toward a space exploration type job based on that fascination and passion for science. However, there are also plenty of other ways. If science isn't your jam, there are other ways to get involved. And I guess I'm an example of that. That wasn't my background. I came in certainly more from the enthusiast side of things, and the idea that communication is so important. It's so important to bring people together and to communicate about what's being done by the scientists. So there's those opportunities. There's business planning, finance, everything that you can imagine in any other business is needed in the space community as well. Manufacturing, so think about what it is that you already are passionate about, and then think about where that applies in the space field, because I bet it will, whatever it is that you want to do. And then I believe that there's a pathway out there for you. And you could always, send us a note too if you want some ideas.
Great. We are out of time. So I want to thank our panelists very, very much. This was wonderful. and wish everyone a wonderful, wonderful Planet Fest and a fabulous Mars landing for, in case anyone's interested in Thursday's landing. All right, everyone. Good luck and have fun. Thank you.
Awesome. Thank you
And
all
good
so
night.
much for coming.
Huge thank you to our panelists today for sharing their expertise with us. Please visit the exhibitor area to meet